Hey guys, so this next lesson is a continuation of the same section that we've been working on, except now we're measuring segments with something called segment addition. So I will define what it is and then we'll do a few examples. All right, here we go. Okay, so segment addition postulate. Postulate is basically just like a rule in geometry, something that's true. It says if Q is between P and R, so let's label this Q is between P and R, then PQ plus QR equals PR, the whole thing. So basically just says that when you have a segment with smaller segments inside of it, all the little ones inside add together to equal the whole thing. So that's segment addition. I have a few very basic examples here, and then we'll do some more algebraic ones. So this one, we're given B is between A and C. We're given AB is 11. You always want to label the picture. BC is 4, and we want to find AC. So based on segment addition, AB plus BC would equal AC, the whole thing. So we were told that AB is 11, BC is 4, so therefore AC is going to be 15. Pretty easy. Now, if you were doing this on your own, you wouldn't have to write out all these steps. I'm kind of just showing you so you understand where the 15 is coming from. Okay, this one, AL is 26. TL is 16. Find AT. So again, small segment AT plus small segment TL equals big segment AL. This time we were given TL is 16. We still don't know AT. And we were given AL is 26. So we're not just going to simply add these two numbers together. I'm sure most of you are probably thinking right now we would subtract. So if I wanted to solve for AT here, I would subtract 16. So that means AT would be 10. And again, if you looked at this and immediately knew AT was 10, you do not have to show out all this work. Okay, so those are some basic examples. Next example has some algebra, still pretty easy. The last one is going to be a little bit more difficult. So for this one, we have H is between G and I. So we need a segment H, I. Oops, just kidding. H is between G and I. Okay, so G is here. And then H is somewhere in the middle. It doesn't matter where you put it. Okay, now we're given GH is 2x plus 2. HI is 3 times the difference of x and 1. And GI is 29. So again, segment addition says that if I add GH and HI, it will give me GI. So we can just plug in what we know. GH is 2x plus 2 plus HI, 3 times the difference of x and 1 is equal to 29. So there's your equation. So sometimes in geometry, we have to write an equation that represents the picture. I also put some steps over here to the right. So I realized I didn't point those out. First, you always want to draw and label a picture. Then you want to write an equation that represents the picture, represents the relationship that you know. Like whatever you know is true about the picture, you write an equation to show that. And then now we have to just solve. So over here, we're going to distribute. So this is going to be 2x plus 2 plus 3x minus 3 equals 29. Now we can combine like terms. So like this 2x and the 3x, and then the 2 and the negative 3 would be like terms. So 2x and 3x is 5x. 2 and negative 3 is negative 1. Add 1 to both sides. So 5x is 30. Divide by 5. X is 6. Okay, so that's how you find x. Step 3 says plug in x to find the missing segment lengths. And so what I mean by that is if you take a look at the directions, it said find x, the measure of GH, and the measure of HI. So I'm going to do that down here. Zoom out a little bit so I can see it all. So GH, if you look up here, is 2x plus 2. We just found x was 6, so I can plug in 6 here. So it's going to be 2 times 6 plus 2. That's what I mean by plug in. 2 times 6 is 12. 12 plus 2 is 14. So that means GH is 14. And then you do the same thing for HI. So it's 3 and then 6 minus 1. 6 minus 1 is 5. 5 times 3 is 15. Notice 15 plus 14 is 29, and it should be. So in the end, your segments should add together to equal the big one. So that's one that has some algebra. Still on the easier side, or should be on the easier side. This last one is definitely a challenge. So let's take a look at this picture. Definitely a more complicated picture than the other. The other one, we just had, one big segment, and then we had two smaller segments inside of it. Notice on this one, we are given the whole segment, EH. So 12x plus 18 represents the whole thing. Then notice now we have these three other segments. So we have, let me erase this real quick. We have 5x plus 27 is from E to G. So from E to G is 5x plus 27. 25 represents F, H. And then this 3x plus 19 represents F, G. So basically what we have to do when you have a complicated picture like this with a lot going on is we need to figure out how we can use these smaller segments, this one, and this one, to write an expression that would represent the length of the big segment. Because this 12x plus 18, we can put on one side of the equation because we know that's the whole thing, right? So now we have to think about, well, would I just add these three small ones? Is that equal to the whole thing? Well, no, because they're overlapping. So then you have to think about, okay, how can I manipulate these to make it be the whole thing? And so what I like to look at is I like to look at the segments that go from end to end. And what I mean by that is, see how this 5x plus 27 goes from E to here, and this 25 goes from here to H. So these two segments, they overlap, yes, but they do go from end to end. So do you notice that if I were to cut the 25 here at G, do you see how this plus this would equal the whole thing? So what we need is we really only need this part, but we don't have that part, but we can figure it out. So if we take this 25, notice that where they overlap happens to be FG. So if we can take the 25 and subtract this overlapping piece, that would represent this little piece. So here's what we do. We're going to have one small piece, this one, plus the other small piece, which is 25, and we're going to subtract the overlapping piece. And then we just solve for x. Okay, sorry guys, I'm having a hard time with my stylus and I've come this far, so I don't want to have to switch over to my Elmo. But basically what I did is I distributed, and from here you would combine like terms. So you would combine 5x and negative 3x. Oh, now it seems to be working. To get negative 2x, and then 52 and negative 19 would give us 33. Equals 12x plus 18. Then from here, you're going to add 2x to both sides. Whoops. You're going to add 2x to both sides, subtract 18, and you end up getting 15 equals 10x. Lastly, divide by 10, and you get x equals 1.5. Okay, it's going to stop working again, I guess. So once you get x equals 1.5, you have to answer the last question, which said to find FG. So FG as you can see, is 3x plus 19. So you're just going to plug in. You're going to do 3 times 1.5 plus 19. This looks terrible, sorry. You're going to multiply 3 times 1.5 is 4.5. 4.5 plus 19 is 23.5 would be your final answer. And so I'm going to have you try one or two of this type just to see how you would do, make you think a little bit more. If you need help, feel free to come back and I can help you, or you can come for ACT Lab later too. All right, so that's it. Please let me know if you have any questions, and yeah, have a great day.